Okay, today we're working on solving one-step equations with multiplication and division. And what that means is we are solving for our variable. We need to isolate the variable, which means we need just the variable on one side of our equation. We need to get rid of everything else on that side of the equation. So just a review of our inverse operations. The inverse of multiplication is division, and the inverse of division is multiplication. So here, when we have a number and a variable right next to each other, this means multiplication. So we can pretend there's an imaginary multiplication sign there. And so to isolate A, to get it all by itself, we need to do the inverse operation of multiplication. So we need to divide. We divide by 6. Everything we do to one side of our equation, we have to do to the other side of our equation. Now 6 divided by 6 equals 1. And if we have 1a, we're left with a. So we can cancel out our 6's. And we are left with a equals 36 divided by 6, which is 6. All right, let's do another example. 4 equals 2v. Now here we're doing the same thing. We still have multiplication, so we need to do the opposite. Just this time, our variable is on the right side of our equal sign. So don't let that confuse you. We're still just isolating our variable. So again, I need v all by itself. So I need to divide by 2. Everything I do to one side of my equation, I have to do to the other side of my equation. Here my 2's cancel out. 4 divided by 2 is 2. Equals v, or v equals 2. All right, let's try some division examples. So x over 2 equals 7. Now remember, this fraction bar is the same thing as division. We're dividing x divided by 2. So again, I need to do the inverse of addition, which is multiplication. So I am multiplying this fraction by 2. Everything I do to one side of my equal sign, I have to do to the other side. Now again, 2 divided by 2 is 1. So our 2's can cancel out, and I'm left with x equals 7 times 2, which is 14. Okay, next we have 2 over 3x equals 2. Now, I want to isolate for x, and this is a specific example. So here we're going to use what we call a reciprocal, or a multiplicative inverse. And we use this to solve multiplication or division equations that contain fractions. And a reciprocal is just a flip. So I flip 2 over 3, which is 3 over 2. I'm just multiplying by 3 over 2. Everything I do to one side of my equation, I have to do to the other side. And the reason this works is because 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1, so these cancel out. And I'm left with x equals 2 times 3 over 2. Now remember, 2 is the same thing as 2 over 1. And when we multiply fractions, we multiply our numerators and then we multiply our denominators. We don't have to worry about common denominators when multiplying. So 2 times 3 is 6, and 2 times 1 is 2. Now we can simplify this to x equals 3. Here we have x over 1.2 equals 3.1. So I need to do the inverse of division, which is multiplication. So I'm multiplying both sides by 1.2. My 1.2's cancel out. And so let's do a quick review of multiplying decimals. So when we multiply decimals, we don't necessarily have to line up our decimals. That's really important to remember. We line up all of our numbers to the right. And we start by multiplying like normal. So 2 times 1 is 2, 2 times 3 is 6. I hold this place with a 0. 1 times 1 is 1, 1 times 3 is 3. And I add them together. Now I have to count how many digits are on the right side of each of my decimals. So here I have 1, here I have 1, and together 1 plus 1 is 2. So I start on the right side and I jump twice inwards. So my answer is 3.72. Last example. 0.2x equals 2.4. Now I'm multiplying here, so I need to do the inverse, which is division, in order to isolate my x. Everything I do to one side, I have to do to the other side. My 0.2's cancel out. And so when we are dividing decimals, we want to make sure that our divisor is a whole number. So I need to move this around. I'm going to move my decimal once to the right. So now my divisor is 2. And so everything I do there, I have to do here. So I jump my decimal over once and I move it up. And now I divide like normal. So 2 divided by 2 is 1. 2 times 1 is 2. I bring down my 4. 2 divided by 4 is 2. 2 times 2 is 4. I subtract and I'm left with just 12. So x equals 12.